after metal and non-metal, then we also have another very important class of electrode, that is metal insoluble salt, anion electrode. Metal insoluble salt, anion electrode. This is where we have a redox reaction with the insoluble salt, which is in the solid form, precipitate form, but involved in the reaction. For example, here AgCl, Cl minus, AgCl, Cl minus. This total combination will act as a half cell, either oxidation half cell or reduction half cell, again like any of the metal ion electrode or non-metal ion electrode. Like that, this also will act as a electrode, either oxidation half cell or reduction half cell. This particular case, this represents the oxidation half cell. Here it is the cell reactions, if you write, it is a Ag solid to Ag plus aqueous plus electron, right. And the next is that it is, so here it is the Ag gets oxidized to Ag plus, this is a oxidation, and then this can be written as AgCl to AgCl reduction to Ag plus Cl minus, or Ag plus Cl minus to AgCl. This is AgCl plus electron. This is reduction half cell. If this, the representation can be either this or Cl minus AgCl Ag. Either way you can represent it. When you are representing it like this, for example, these two, if you take, this is the reduction half cell, AgCl electron to Ag and Cl minus, this is Ag plus Cl minus to give AgCl. So, this can be represented either way, and this is the reaction when this electrode is acting as reduction half cell, and this is the reaction when it is acting as oxidation half cell. Like zinc gets oxidized to Zn2 plus, copper gets oxidized to Cu2 plus. Copper either gets oxidized to Cu2 plus when it is in combination with zinc, Cu2 plus gets reduced to copper when it is in contact with zinc, or Cu gets oxidized to Cu2 plus when it is in contact with silver. So, like that, copper can act as both oxidation half cell or reduction half cell. Similarly, this particular half cell can act as either oxidation half cell or reduction half cell. Anyhow, the actual reaction is either, here if you look at it, it is Ag to Ag plus, and reverse is Ag plus to Ag, but only thing is it is through saturated, the insoluble salt AgCl. In the case, if it is silver nitrate, then simply we write Ag to Ag plus like this, either this or that, but because it is AgCl, so it will be like this. And when it comes to its construction, that here you have Ag plus solution, and here it is the AgCl gets precipitated. Now, into this added is NaCl solution. NaCl solution, when you add it up to the solution of Ag plus, when NaCl to Ag plus solution, when you add NaCl, Ag plus Cl minus, what you will get? It is AgCl solid. That precipitate will get settled at the bottom, and a platinum wire is placed into it, okay, or a silver wire. Of course, in the case of silver, it is a silver wire, that is enough, no need of a platinum wire. It is a silver wire that is dipped over here, and this is a silver metal. So, it is Ag plus solution, into this NaCl is added, NaCl is added. When NaCl is added, here the precipitate is formed over here and a silver wire is kept in this. So, this combination will give silver, this is silver wire, this is Ag plus ion solution, AgCl precipitate, and to the from this Cl minus. So, AgCl, Cl minus. So, the AgCl minus combines with Ag plus ion solution and will get AgCl. This is the cell representation and this is the cell reaction and this is the cell construction. For this also it will have certain measurable EMF. Based on the EMF, whether it will be known whether it is acting as oxidation of cell or reduction of cell. Other similar examples are besides AgCl, Cl minus, then what we have is the calomel electrode and also we have lead and lead sulphate, that we will see now.